This video is going to go over all of the trends on the periodic table. As a review, the first periodic table was created by a Russian scientist named Dmitry Mendeleev. He arranged the elements by atomic mass, and he found that when he arranged them that way, they had similar properties on certain levels. He first published the periodic table in 1869, very long time ago. And he actually was able to predict where undiscovered elements should exist by leaving empty spaces on his periodic table, which is pretty neat. And at that time, noble gases were not part of the periodic table. Remember, noble gases are that group 8A, that last column on the periodic table that starts with helium. Here's an example of his periodic table, what it looked like. You can see it looks a little bit different than the one that we have now. So you can see on here the empty spaces that were left. Those are the places where he predicted elements would be, and he actually found that there were elements that fit in those places, they just weren't discovered yet. Okay, now let's talk about the periodic table that we all know and love, the one that you have printed out, the one that's on the wall that you're familiar with. It was created in 1911 by a guy named Henry G.J. Moseley, who was English, and he found that the pattern of elements worked best if they were arranged by number of protons, otherwise known as the atomic number. That's the same as the number of protons, you might remember. So obviously, that's the arrangement that our current periodic tables use. And when we talk about periodic trends have to do with the properties of the elements and how they change in a predictable way as you go up or down or to the left or to the right on the periodic table. And just to remind you, when we talk about groups are the columns that go up and down, 1 through 8A, and then the transition metals. And periods are what we call the rows that go from left to right. Alright, first trend we're going to talk about is the atomic radius. Atomic radius is basically a fancy word for the size of atoms of an element. So in an element, atomic radius measures the size of its atoms. Typically that's measured from the nucleus to the edge of the electron cloud. You would just, like here, you would measure that distance, kind of like the radius of a circle goes from the middle of a circle to the outer edge perimeter. But the boundary of the electron cloud is not really well defined. So when we look at this trend of atomic radius, it decreases as you move from left to right across the periodic table, meaning that it increases from right to left. So if we were to draw our arrow on here of the way it is increasing, it's going to increase as you go from right to left, and it's also going to increase as you move down. So you can see that on here, if we were to draw a line diagonal in that direction, that when you start up here in the top right-hand corner, those are the smallest radius or size, and when you end down here in the bottom left-hand corner, those are the largest radius. Alright, let's put that knowledge to the test. Take a minute, look at the periodic table, think about the way the trend goes, and see if you can figure out which of these have a larger atomic radius for these 3 questions. Alright, another little review of something that you've heard before, cations and anions. Remember that ions are just atoms that have a charge. They can have a positive or negative charge. And an anion is an atom with a negative charge. Anions form when valence electrons are added to the outside energy level. Remember when we learned this before, we kind of talked about how it's backwards. When you add electrons, that gives it a negative charge. And we said the reason was because electrons have a negative charge. So it's like saying, I'm adding -1, which gives you an overall negative charge. So anions gain electrons and have a negative charge. Cations, on the other hand, are atoms with positive charges. So these are atoms that have lost valence electrons. Those valence electrons have been removed from that outer valence shell. And kind of a cute way to remember these, cations are positive. So if you think about cats, positive, kind of a cutesy way. And anions, those are the ones that come second when you write the formula, like sodium chloride. The anion, the negative one, is the chlorine, and you add that ending "ide." So you can think about anions, you like to add "ide" to those. Alright, time for the second trend. This is ionic radius, or ionic radii for plural. So this is basically an atom gets bigger when electrons are added, and atoms get smaller when electrons are removed. Finally, something that makes sense. You add and it gets bigger, you take away and it gets smaller. So when we look at the direction of this trend, it decreases as you move from left to right. So again, if we say how it increases, it's going to increase as you move from right to left. And it also increases as you move down. Now this might look familiar because it actually goes the exact same direction as atomic radius. So really you don't have to memorize two trends here, you just have to remember one, and remember that that trend is true for both ionic radius and atomic radius. Alright, third trend, moving right along, ionization energy. Ionization energy is the energy that it takes to remove an electron from a neutral atom. Electrons can be removed from an atom if they use enough energy. Again, we call that energy ionization energy. In general, when we're talking about ionization energy, our metals, our positive ions, cations, freely give their valence electrons. So it costs them less energy to give away those electrons. They want to give them away. Nonmetals are negative anions. They like to hold on to their electrons more strongly. So we would say that the cost for losing those electrons is higher. They have to pay more in a way. So if you think of ionization energy as money, the metals you have to pay less to lose them. The nonmetals you have to pay more to lose them. So when we look at this trend and the way that it goes, ionization energy as a trend increases from left to right. So as you go from left to right, they generally get higher in ionization energy. It also increases as you go from top to bottom. So you might notice that this is actually the exact opposite direction of those two other trends we talked about, atomic radius and ionic radius. So ionization energy, it goes the opposite way. It increases as you go up, and it increases as you go from left to right. Alright, let's try some out. Take a look at these three questions and see if you can figure out which one has a higher ionization energy. Alright, fourth trend, talking about electronegativity. Electronegativity has to do with an atom that's in a compound, not by itself. Electronegativity is just a big word for measuring how strongly an atom attracts electrons when it's in a compound. So you can think of it like this. You can think of an element that's very electronegative being a bully. And if you think of the atoms as little kids, the electrons as the toys, the bully is trying to keep all the toys to himself. He's very strongly attracted to those electrons. So if you think of fluorine, fluorine is in the corner, and it is the biggest bully of them all. It's the most electronegative. And this scale of electronegativity, the way they set it up is they took fluorine, the one that was the most, and assigned it as a 4.0, and then they gave numbers to all the other elements by comparison to that one that was the largest and the most electronegative. So looking at this trend in the direction, electronegativity is going to increase as you go from left to right, and it's also going to increase as you go from top to bottom. So you might notice that this one is the same exact direction as ionization energy. So you can remember ionization and electronegativity, they increase going up and to the right. And the two we talked about before, atomic radius, ionic radius, those increase going down and to the left. So let's see if you can figure these last three out. Which has the higher electronegativity?